Hello students, good morning. This is the second session of your geometrical chapter, that is quadrilaterals, right? We are already completed one session. In that we will learn some basic concepts that is related to the quadrilaterals. For example, we learnt already polygon, right? Types of the polygons and interior and exterior on the polygon, the parts of the polygon, right? Next one, regular polygon and irregular polygons. Next, concave and convex polygon. These all things we already learned in the first session, right? So today we are going to discuss the definition of quadrilateral, and some properties that related to the quadrilaterals. Some properties that is related to the quadrilaterals. Okay, let's come to the second session of the chapter quadrilaterals. In that, first concept is quadrilaterals. This is the main chapter name of your first chapter in geometry, right? So quadrilateral, you already know quadrilateral means a plane figure which has four sides, or a quadrilateral is a polygon which is bounded by four line segments, For example, if I take here one example, that quadrilateral A, B, C and D. ABCD is a quadrilateral. Because it has four sides. First side, second one, third one and fourth one. So the polygon has four sides, hence we are call it as a quadrilateral. Now come to the basic points that is related to the quadrilaterals. As you all know, quadrilateral has four sides: AB, BC, CD and DA. So quadrilateral has four sides. What are the four sides here? AB, BC, CD and DA. Next, the same quadrilateral has four angles. What are the four angles? Angle A, angle B, angle C and angle D. So these are the four angles of the given quadrilateral, and it has four vertices. Vertices means corner point of the polynomials, corner point of the polygons, right? So what are the four corner points? Vertices, right? So A is the first vertex, B, C and D. These all corner points are called as vertices of the polygon or vertices of the given quadrilateral. Okay, and just observe these points A, B, C, D. By joining the opposite vertices, we get one term, that is diagonal. Diagonal is the line segment. Which joins opposite vertex, of any polygon, So AB is the line segment, or AB is the diagonal which joins from point A to C. And we can draw one more diagonal, BD or DB. So in quadrilateral there are four sides, four angles, four vertices and two diagonals. How many diagonals are there in quadrilateral? Two diagonals. What are the two diagonals? AC is the first diagonal and BD is the second diagonal. AC is the first diagonal and BD is the second diagonal. So these are the some basic concept that is related to quadrilateral. Okay, now how we can denote the quadrilaterals? Usually when we are representing or when we are going to denote the any polygon, it is always in the cyclic systematic order only. For example, here you are observing ABCD is a quadrilateral. That quadrilateral can be represented or denoted by ABCD is a quadrilateral. If I start from A, then ABCD is a quadrilateral. Or now start from B, BCDA is a quadrilateral. It is also in the cyclic order only, no? So third one, start from C, CDAB is the third type of the representation of the same quadrilateral. Now one more letter is there here, D, A, B, C. So these are the four ways to represent a quadrilateral. If we are going to represent one particular quadrilateral, we can represent in four ways. So these are the four ways. But we cannot represent like this: A, C, B, D, or B, D, C, A. Just observe this point: A, C, B, D, A, C, B, D, and second one B, D, A, C. So is it in cyclic order? No. So we cannot represent these types. This is completely wrong representation of the quadrilateral. While we are going to represent a particular quadrilateral, it should be in the cyclic systematic order only. You can start, either you can start from A or start from B or C or D, but it should be in the cyclic order and systematical order. So this is the representation way of given quadrilateral. Okay, let's move to the next concept, that is adjacent sides and adjacent angles. Adjacent sides and adjacent angles. You are already learnt in the previous year adjacent angles and adjacent sides, right? So adjacent sides means what? The two sides which is originated from the same point or same vertex, right? And adjacent angles means the two or more angles, the two angles formed by the common side, the two angles which is formed by the common side, right? Let's take one example that is related to adjacent sides and adjacent angles. Suppose if I take one rectangle here, A, B, C and D. A, B, C, D is a rectangle, right? So how many sides are there here? Obviously 4 sides, 4 angles and 4 vertices, right? So this rectangle has 4 sides, 4 angles and 4 vertices. We need to write the adjacent sides first. Adjacent sides means what? The two sides having one common angle. One common angle, or it can also defined as the two sides which have one common vertex. For example, just observe this one. A is the vertex. From this vertex, the two line segments are there. AB is the first line segment and AD is the second line segment. So these type of the sides are called as adjacent sides. So adjacent sides are having common vertex or common angle. Either you can consider it as a common angle or common vertex. And in every quadrilateral, we can write 4 pair of adjacent sides. 4 pair of adjacent sides and 4 pair of adjacent angles. Let's come to write the first pair of the adjacent sides. First one, AB and AD. AB and AD. AB and AD are the two sides which is originated from the point vertex A, which is originated from the vertex A, right? These two line segments or these two sides are having common vertex, that is vertex A, right? Next, second one. Now take vertex B. What are the two sides which is originated from point B or which is originated from vertex B? BA BA and BC. BA and BC are the two sides which is from or which is originated from the vertex, B, right? Next, take to the third point. What are the two sides originated from vertex C? CB, this is one side, and second one CB or CD, which originates from point C, right? Last one DA or DC. DA or DC are the two line segments which is originated from the point D, right? So or it has a common vertex D. So these type of the sides are called as adjacent sides. Okay, so adjacent side means what? The two sides having common vertex or common angle, right? So we are writing here four pair of adjacent sides. So these are the four pair of the adjacent sides of the given quadrilateral. Let's move to the next concept, that is adjacent angles. In adjacent sides, the two sides are originated from the same vertex or common vertex. So how you can define the adjacent angles? Adjacent angle means the two angles. You can take any two angles. The two angles having one common side, and as I already told you, in the particular quadrilateral we can write four pair of adjacent angles. So what are the four pair of adjacent angles? See one by one. Adjacent angles. Just observe this given rectangle ABC. Angle ABC is the first angle, right? Take one more angle. Angle DAB. These two angles, angle A and angle B, having one common side, that is AB. Can I repeat once again? Just represent the angle A. How you can write this one angle? Angle ABC. Angle ABC. The center, what you are representing the angle, no, that vertex should be lies in the center of the angle, right? So angle ABC, or one more angle DAB. So these two are the angles, right? Observe these two angles. In these two, one common side is there, AB and AB, right? So these type of the angles are called as adjacent angles. So how you can define the adjacent angles? The two angles having common side is called as a adjacent side, and in one particular quadrilateral we can write four pair of adjacent angles. So let's write one by one. Angle A and angle B. First pair, angle A and angle B. Angle A and angle B. Second pair, angle B and angle C. Angle B and angle C. Third pair, angle C and angle D. Angle C and angle D. And the last pair of the quadrilateral is angle D and angle A. Angle D and angle A. So these are the four pair of adjacent angles for the given quadrilateral. Clear? So angle A and angle B, what is the common side here? Which is the common side? AB is the common side. AB is the common side for these two angles, right? For angle B and angle CD, angle B and angle C, which is the common side? BC is the common side. For these two angles C and D, which is the common side? So common side is CD. and the last one, for last two angles, the common side is AD. You are getting idea now, right? For adjacent sides, angles are common or vertices are common. For adjacent angles, sides are common. Clear? So these all about the concept related to adjacent sides and adjacent angles. And one more thing, adjacent sides or adjacent angles is also called as consecutive angles. Consecutive angles, right? In simple words, the adjacent sides and adjacent angles are defined as these angles are formed by side only. While you are observing these angles and sides, just observe AB and BC. These two sides are formed by their sides only, right? So usually adjacent sides and adjacent angles are formed by same side or side by sides only. Clear? So this is all about the adjacent sides and adjacent angles. So how many pair of adjacent sides and adjacent angles you can write in the quadrilateral? There are total 4 pair of adjacent angles and 4 pair of adjacent sides are there in the particular given quadrilateral. Okay. Let's come to the next concept, that is opposite sides and opposite angles. Opposite means what? Which is exactly opposite to the given side or given angle. Can I take one example here? Yes. First one, again consider one rectangle PQRS. PQRS is a rectangle. PQRS is a rectangle. Just observe the opposite sides. Opposite sides means which is exactly in front of the given side, right? So PQRS is a rectangle or quadrilateral. So how you can write the opposite sides, or how you can define the opposite sides? Opposite sides means these are the sides which do not have any common angle. The two sides which do not have any common angle. For example, PQ and SR. These two are the sides, no? So these two sides will not have any common angle. They are formed by separated only. They are formed by the different vertices only. So these two sides are called as opposite sides, right? So opposite sides, how you can define the opposite sides? Opposite sides are the sides which do not have any common angle or which do not have any common vertex point, right? So in particular quadrilateral, we can write two pair of opposite sides. Two pair of opposite sides. Opposite sides. So what are the two pairs? PQ. First pair is PQ. Which side is exactly opposite to the PQ? That is SR. PQ and SR is the first pair. Let's come to the second pair. What is that second pair? Remaining two sides. What are the remaining two sides here? PS and opposite to the given PS is QR. So these two are the two pair of opposite sides of the given quadrilateral. Okay. Next, going to the topic, that is opposite angles. Opposite angles. Opposite angles. As we are already discussed in opposite sides, the two sides which do not have any common vertex or common angle, so that type of the sides are called as the opposite sides. So how you are going to explain the opposite angles? So opposite angles means, just move to the previous concept, that is adjacent angles. In adjacent angles we have one common side, right? You are observing here in adjacent sides AB and B, angle A and angle B, these two angles are formed by the common side AB. But in opposite angles, In opposite angles there will be no common side. There will be no common side. So how you can define the opposite angles? Two angles, any two angles, you can take any two angles which do not have any common side, which do not have any common side. So these type of the angles are called as opposite angles. And one more thing, in the particular given quadrilateral we can write only two pair of the opposite angles. So what are the two pairs here? First pair is angle P and angle exactly opposite angle R. Second pair angle S and angle Q, angle S and angle Q. Why we cannot consider angle P and angle S? Because these two angles having a common side, that is PS, right? So these kind of the angles are called as adjacent angles, but opposite angles does not have any common side. So that's why we are considering non-opposite angle. So angle P and R are the opposite angles which do not have any common side, and angle S and angle Q are the two opposite angles, again these two angles which do not have any common sides. So in given quadrilateral we can write two pair of opposite angles and opposite sides. So this is all about the adjacent sides and adjacent angles, and adjacent opposite sides and opposite angles. Let's move to the next concept, that is the property based on the quadrilateral. As we have already discussed in the previous class, the sum of all the angles of the quadrilateral, is 360 degree. It is already discussed in the first session, right? The interior angle of triangle is 180 degree and the interior angle of quadrilateral is 360 degree. We will prove the given statement, alright? So here I will take one quadrilateral A, B, C, D. ABCD is a quadrilateral. What is that given statement? The sum of all the angles, of a quadrilateral is 360 degree. It means here you need to prove the sum of all four angles. While you are adding four angles of the given quadrilateral, that should be equal to the 360 degree only, right? So ABCD is a quadrilateral. ABCD is a quadrilateral. What is the given data here? ABCD is quadrilateral. ABCD is a quadrilateral, right? What you have to prove? What you have to prove? The interior, the sum of the interior all angles should be equal to 180 degree. It means angle A plus, angle B plus, angle C plus, angle D is equal to 360 degree. You need to prove this one only, right? So take some construction part here. Construction. What you have to construct? By joining any two opposite vertices we get a diagonal. By using the diagonal only we will prove the given statements. So you can join any two diagonals. Here I will join the line A and C. Draw the line from point A to C. So AC is the diagonal. Draw a diagonal AC which is from point A to C, right? So let's come to the proof of the given statement. Observe the diagram. ABCD is a quadrilateral. While you are constructing one diagonal, the quadrilateral divided into two parts. So what are the two parts there? They are the triangles, right? You already know the interior angle of the triangle is always equal to 180 degree. When we draw one diagonal in quadrilateral, that quadrilateral is divided into two parts and each part is a triangle, right? So what are the two triangles here? What are the two triangles? First triangle is triangle ABC. This is the first triangle, right? Second triangle ADC. ABC is the first triangle and which is the second triangle? ADC. ADC. So these are the two triangles formed by the diagonal AC, right? Let's take one by one triangle. In first triangle, in triangle ABC, write individual angles. Angle BAC, angle BAC plus angle BCA, angle BCA plus, so this is common angle B, which is equal to 180 degree. Why I wrote here 180 degree? Because the interior angle of any triangle is always equal to 180 degree. So these all the three angles of a given triangle. So interior angle of this triangle is equal to 180 degree. Consider this is equation 1. One more triangle is there here. What is that triangle? In triangle ADC. In triangle ADC, again take individual angles, each individual angle. Angle DAC plus angle DCA plus one more angle D is equal to, again the sum of the interior angles of the triangle is equal to 180 degree. So this is also 180. Consider that statement as equation 2. Add equation 1 and 2. Add equation 1 and 2. What we will get by adding equation 1 and 2? Write first equation. Write that first equation. Angle BAC plus angle BCA plus angle B plus, write the LHS part only first. LHS part of the first equation. Next LHS part of the second equation. What is that LHS part of the second equation? LHS part of the second equation is angle DAC plus angle DCA plus angle D. Now write the RHS part. In RHS part, in equation 1 180 degree, in equation 2 also 180 degree. So 180 plus 180. Clear? By adding the two angles, we get this kind of statement. Here observe the diagram. Angle A and angle C is divided into two parts. We need to add these two angles, or we get one complete angle by adding these two individual angles, right? So again we can write the given statement by rearranging. For example, angle BAC, just observe the vertex A, it is there in one more angle. Where is that? So this one, angle DAC, angle DAC, make it one separate angle, plus similarly angle C is dividing as a two angles. We need to get complete one angle by adding these two angles, right? So angle BCA plus one more C is here, this vertex C, angle DCA plus, what are the remaining two angles? These two are already complete, these two are already complete. Remaining two angles, angle B plus angle B plus angle D, right? So by adding angle BAC, DAC, what we will get? Observe the diagram. Angle, by adding angle BAC and angle DAC, by adding these two angles we get a complete angle of A, right? By adding these two angles we get one complete angle, that is angle A. Again, one more term is there, angle BCA and angle DCA. By adding these two angles, angle BCA and DCA, we get one complete angle, that is angle C. So I wrote here angle C, and remaining two angles, angle B plus angle D. Let's move to the first one. 180 plus 180, 360 degree, right? The sum of the two triangles, one interior angle of the triangle is 180 degree and interior angle of the another triangle is also 180 degree. By adding that two we get 360 degree. So this statement we can rewrite it as angle A plus angle B plus angle C plus angle D is equal to 360 degree. It means the total interior angle of any quadrilateral is always equal to 360 degree. Hence we proved. So this is the proof of the given statement. What is that given statement? The sum of all the angles of a quadrilateral is 360 degree. Okay, clear? So this is all about the interior angle of the quadrilateral. Interior angle of quadrilateral means by adding all the four angles of the quadrilateral, which is always equal to 360 degree.